Hello everyone, welcome to the lesson Storage Level 200. My name is Flavio Pereira and I'm part of the enablement group at Oracle Cloud Infrastructure. This lesson will cover on details topics that were not covered on the Storage 100 level course. So it's highly recommended that you watch the first storage lesson in order to follow with the content on this course. So here's our safe harbor statement. I'm going to pause for a few seconds here so you can read the statement. All right, so on this lesson, we're going to cover all the storage aspects of Oracle Cloud Infrastructure. We're going to cover NVMe SSD devices, block storage volume groups, and performance aspects of that. File storage service performance metrics as well, object storage, and Amazon S3 compatibility APIs, along with some data backup and migration options that you can execute it in Oracle Cloud Infrastructure. So here's one slide that gives you a high-level overview of all the storage options that we have available. As you can see, you can go from local NVMe devices all the way to archive storage. You can see the type, the durability, capacity, and unit size for each one of the storage options available. All right, it really depends on the workload that you're trying to move over to OCI or implement in OCI, and you can find the storage that will best fit for your workload here on that presentation. So let's talk about local NVMe SSD devices, right? So some instances in OCI, they have locally attached NVMe devices. So NVMe is really high performance storage that's ideal for big data workloads, for HPC workloads, and any other workload that can benefit from high performance storage. So note that those devices, they are not protecting in any way, right? So the individual devices locally installed on your instance. You can see all the shapes that we have available, all that has dense I/O on the names, means that we have an NVMe SSD locally attached devices on it. So bare metal virtual machines, you can find the number of drivers available and the amount of storage associated to it. Right, one of the key differentiators here on Oracle Cloud is that the data on the NVMe SSD is persisted, which means if you rebooted the server or if you stop the server for any reason, so you can restart your server again, get access to the server, and your data will be saved. Your data will be there on the NVMe SSD device. It's not going to be deleted or purged on once you pause or once you stop the instance, right? So the only way that the data will be deleted off NVMe SSD is if you actually terminated the instance. So if you don't terminate it, if you just pause or stop, your data is protected, and when you bring back your instance again, you still have access to that data. So let's talk about protecting NVMe SSD devices, as I mentioned, right? So as we have NVMe locally attached to the instance, you have to protect your NVMe, creating what we call a software RAID array on the NVMe devices. So one of the options that you have is creating a RAID 1, which is an exact copy or mirror of the disks that you can have on NVMe to protect your data. You can also have a RAID 10, right, which is a combination of RAID 1 and RAID 0 devices, or a RAID 6 that's good, a block level stripping with 2 priority blocks distributed across all the disks, right? So remember, when you're using a RAID, you're actually losing the usable storage, a little bit of usable storage on the NVMe devices as you're using the devices to create the RAID array. So what you have to do when an NVMe device actually fails. So if NVMe device fails on an instance, we recommend that you right away create another instance with the same amount of storage, right, or NVMe that you actually provision as well, and try to copy the data from that instance to the other instance. So that way you start to protecting the data and start to having a backup of your data in case something went wrong with the NVMe device, right? That's the first thing to do. So there's multiple tool sets you can do it. You can copy data using rsync. You can also attach the block volume to the instance and copy the data from the NVMe to the block volume, and then you can easily attach that block volume to another instance in case that one fail. All right, so there's a couple ways you can do a copy. And remember, right, that if a failed device happens on the array, on the RAID that you created, it's also recommended that you copy the data to another instance or to a block volume. You can just create a backup, even if you still have access to the array. So that way you protect your data and be able to save that in case you need to recover or redo the array on the instance again. All right, let's talk about some NVMe performance. So here's one thing I want to show in terms of performance. Like, we have a tool that's called not a tool that we have, but like we use a tool that's, from Cloud Harmony, which is public available. You can access that tool on GitHub repositories and use that to create your own benchmark on the storage and OCI. So here's one execution of that tool, actually testing one of the bare metal dense I/O shapes, just targeting one of NVMe devices, just one NVMe device of the 8 devices available with that instance. And then we're running a command here to actually do a 50/50 read and write operations on a block size of 4K. So when we do that, you can see here the metrics that's showing. We can get around 500K IOPS on that device, on that unique device, unique NVMe device here. So if I combine all those NVMe devices, I have 8 devices available on the bare metal shape. And when I combine those 8 devices, I can get close to 3 million IOPS on the 50/50 read and write, right? So here's a graph showing if I go just 100% read, I can get almost over to 5 million IOPS here as well. So we're very proud of the numbers that we show here. That tool is available so you can test yourself and execute your benchmarks on your own environment as well. So in our documentation, you can find more details on how to use that tool. Right. So as performance is a big concern for us and a big thing that we want to highlight it in Oracle Cloud Infrastructure, we actually have an SLA for NVMe performance. So all the shapes that I mentioned, we have the dense I/O, right? We have a minimum supported IOPS that we can offer and cover under our SLA, right? All the tests, like I said, was executed using a 4K block. In this case, with 100% random write on dense I/O shapes that we executed, all the dense I/O shapes. And you can have access to the Cloud Harmony tool on that GitHub repository to run your own tests. All right, so let's talk about block volume now. So what exactly is the block volume, right? So if you need to a storage that can go from 50 gigabytes all the way to 32 terabytes in a single block volume, you can attach that to a specific instance, and then using through a iSCSI protocol, you can format that device and then put the file system on it and start using on on your instance, right? So very straightforward. You can just attach storage to the instance, and then have access to like very good amount of storage available for your workload. All right. So previously on the first lesson, you went over to some of the block volume options like resizing, clone, backup, and all that. So now we're going to talk about volume groups here on this lesson. So just to give an idea, this is like typical enterprise application storage architecture, right? Where you have virtual machines or applications that actually use multiple block volumes associated to it, right? And then one of the challenges is if you have to take a backup of those volumes and you have to go in one by one, at some point when you execute that, you're actually losing, there's a gap, you're actually losing time in the data. There's a delta data that will be lost because the time that you executed a backup in one volume is not going to be exactly the same time that you executed on the second volume, right? So in order to fix that problem and give the ability for customers to deal with multiple storage associated to servers, you can actually group together block and boot volumes from multiple compartments across multiple compute instances, what we call a volume group, right? So grouping those together, you can use that to create backups and clone. And that we call it's a point in time and crash consistent backups and clones. You can manually trigger a full or incremental backup of all the volumes in a volume group. So you can also leverage coordinated snapshots across all the volumes. Groups for coordinated backups. So here's a picture of that, right? So you have your virtual machine, your application, and you have blocks associated to that server. So you created a volume group, and then after you created the volume group, you said, I want to combine those three volumes together. Then I'm going to create a volume group backup, right? So when you're creating a volume group backup, you can do that creating like a manual backup. If you created, you can create a full or incremental backup, and then you can restore that volume group backup. And when you restore, you can associate that to a new instance if you want, or to the same instance as well, right? So that's will create the crash consistent point in time backup. So there is no downtime required. You can do online. You have your application up and running, for example. You can just go and execute that through the volume, and there is no problem in having the application up and running in order to do those sort of backups. Same thing you can do with coordinated clones, right? You have a volume group, and then instead of creating a backup, you're actually creating a clone of that. So it's a clone volume group. And then when you have a clone volume group, you can actually use that clone to, put in a new set of virtual machines as well, and a new set of applications. So that do a deep disk to disk copy of the entire volume group and all the volumes on that volume group, right? So deep disk copy. This create a new completely isolated volume group and a new set of volumes that are also completely isolated from their corresponding source volumes. And a clone is actually a great feature. A clone can be attached and used as a regular volume when its lifecycle state becomes available. So usually within seconds, you can have access to that clone that you created and then have access to the data there. Okay. Yeah, last portion is the hydration, right? The hydration will continue to happen in the background. So when you're creating a clone, there's a hydration process that's happening behind the scenes that will be executing during the cop over. So there might be a little bit of latency spikes for blocks or data that were not copied over yet. So you can accomplish that through the console. You can actually create volume groups through the console. The console, you can go and create a volume group, right? And select the compartment that you want, and then associated the volumes on that specific compartment, right? So you can just click on the plus button and add more volumes if you will. And then once you do that, you can see the name that you gave for your volume group. And then from there, once it's available, so you can see there's 3 volumes created here. I can just go and create a volume group backup or create a clone. So if I do backup, I have the option to do a full backup or incremental backup as well. All right, so block volume cross region backup. So you actually can copy backups to a different region, right? And that will be possible to apply cross-region copy to manual or scheduled backups, right? So why that's important? Why is the main use case for actually copying a block volume between regions? So the main case is for disaster recovery, right? So you can have a copy of the data in one region, let's say Phoenix, and you want to move that to Ashburn. You can have that data copied over, right? So migration as well. So if you do a migration from one region to another one, it actually helps a lot in copy the data and send that over to another region. So that's one capability that's available. It's actually using an internal Oracle backbone, right? So the data is not going through a public internet, right? So it's actually all through the Oracle internal backbone. All right, so let's talk about block volume performance. So there's 3 aspects of the block volume performance that all the customers will look for. First one is IOPS. They want to understand like how many IOPS they can get on the device, throughput on the disk, and latence as well, right? So those are the 3 aspects you're going to see. All the block volume services use NVMe-based storage behind the scenes on the storage infrastructure. So it's designed for consistency and, be a really great performance as well. So you don't have to worry about RAID on the block volume because everything is actually take care of in terms of replication and all that. So you don't have to worry about creating any RAID configuration for your block volume. So throughput performance on virtual machine instances depends on network bandwidth, and for each shape, it has different bandwidth in terms of networking. So you have to watch out for that. It depends on the shape that you're actually using, along with your storage. That will be impact the throughput of your performance. Right, and IOPS performance is independent of the instance type or shape. Right, it's always applicable for all the bare metal and virtual machine shapes, and for iSCSI attached volumes as well. Right, so here's one chart just to give an idea of the block volume performance. So this one's going to describe the performance characteristics of the service. So you can see the volume size and the characteristics of each of that, right? 50 gig to 32 terabytes. That's the amount of data you can have on the block volume, and incrementals of 1 gig, and the minimum and the maximum IOPS you can get on the block volume, throughput and latence as well, right? And per instance limits, right? You can have 32 attachments of block volume per instance, so it's going to be up to 1 petabyte of data associated to a single instance, right? Okay, so due to the overhead of virtualization, para-virtualized attachments reduce the maximum IOPS performance for larger block volumes. So just be aware of that. When you attach a block volume, you have 2 options. You can do iSCSI or para-virtualized. When you do a para-virtualized, there's a little bit of a overhead on the virtualization portion that might impact the performance on larger block volumes. Here's a simple command that was executed actually to measure the throughput on a single volume. So we're using a tool called FIO. You can install that on your Linux box. It's very easy. You can run fio on the Linux instance and then execute that, right? So when you execute the fio command, looking for 4K block, read and write operations, so you can find the amount of IOPS that's available for each interaction that you executed, okay? So you can also find more information about block volume performance in one of our blogs. So you can see the links here, the documentation as well. And there's a storage review website that actually went over to all the details about Oracle Cloud Infrastructure bare metal instances and the storage. So you can get great content and understand how they measure and benchmark our storage offers. One warning here: so if you're willing to run any benchmark on your own, just be aware that when you run fio or any other benchmark test, just make sure that the data that you don't have any data on your device. So some cases, some tools might delete the data inside of the device. So just be aware of that. So when you run your benchmark, please make sure that you're running that on the safe mode. All right, so file storage service. So as you know from the previous lessons on the Computer 100 level, file storage service is a shared file system, right? It's NFS based, where you can have multiple servers and multiple nodes connecting to the same device, and then having access to a shared unique location to put the data, right? So there's a performance metrics around that as well. So when you're performing read and writes of large blocks, or around 1 megabytes for each terabyte of data stored, so this is what you can expect. Overall read performance at least 100 megabytes per second. An overall write performance of at least 50 megabytes per second, and at least 2,500 read IOPS, right? So the highest levels of performance assume concurrent access that can be achieved by using multiple clients, multiple threads, and multiple mount targets. So I always recommended that you try to run jobs in parallel for FSS, right? So you can maximize the amount of channels connecting to the FSS, right? If you have mount targets, you can have multiple mount targets to give you better network performance too. So that will increase the access and the performance on the FSS. So here's another chart just to give an idea. If you have 1 terabyte on the file system, this is like how many read bandwidth you can get and write and read IOPS based on the blocks, on the size of the block, right? 1 megabyte block and 8K blocks, right? So this table describes the level of performance expected for different size file system, like I said, but although we do not guarantee these numbers, we expect the customers should be able to achieve at least this level of performance in the current file storage service, right? So you can test on your own and get more details on this white paper, this public white paper, where we can go to more details on the file storage performance guide. All right. So to optimize the performance of file storage, you consider some of the guidelines here, right? So the file storage is scaled based on consumed capacity, with large file system receiving more availability bandwidth, right? Like I said, multiple mount targets can help with that, along with the VM shape that you're actually using as well, right? File storage performance increases with parallelism. So if you can run things in parallel, increase concurrence by using multiple threads, multiple clients, or multiple mount targets, like I said. And for best performance, don't set any mount options, such as like R size or read size or right size when mounting the file system, right? It's highly recommended you don't touch any of those options when you're doing that. All right, so object storage. Just to give an overview on object storage, just want to go here and give you like a high availability for object storage. Actually, when you put the data on the bucket, right, on the object storage, so we have, storage servers that actually replicated the data across availability domains. And all that. So your data, it's highly durable, right? It is stored redundantly across multiple storage services, across multiple availability domains. It's highly available. So any loss in data redundancy is detected and actually remediated without customers' intervention or impact. So if one of the services went away, another server can have a copy of the data and heal all the replication and make sure that the data will be available for you all the time. So the service is designed for high availability, right? Multiple safeguards have been placed to build the platform and to monitor the health of the service to guard against unplanned downtime. So Amazon S3 compatibility APIs. So on our object storage, you have the ability to use Amazon S3 compatibility keys. So under your user that you created in OCI, you have an option to create a key that will give access to the S3 compatibility portion. So what that means actually, so S3 API compatibility implies that customers and partners can continue to use their existing S3 tools, right? So SDK clients, third-party tools like Cloudberry or any other third-party tool, they actually interact with S3 storage, right? So they don't have to rewrite their application or rewrite their API calls in order to get access to our object storage, right? So it's fairly easy for partners to keep working with S3 and our object storage, and having that compatibility will help them a lot, right? So here's some of the partner backup options that we have: Commvault, Veritas, Cloudberry, CyberDuck. Some of them you can access and use our object storage in order to create your backup. So data backup and migration options. This is the last part of the lesson here. So in order to achieve that, we have a couple services that can help with data movement in OCI. For example, OCI Storage Gateway. Right, so OCI Storage Gateway, it's actually using an object storage and provide as a virtual storage platform that looks like and behaves like a traditional NAS, right? Since a bucket can have a limited number of objects, one common ask is how you can upload such huge amount of files to it. So for that object storage, it's great, right? So you can segment your file in multiple parts and then upload that in parallel to the object storage. But you can expose that through a NFS mounting point using the storage gateway. So the storage gateway will expose the OCI object storage as an NFS mounting point, and then you can copy the data to that specific NFS mounting point, and that will send that over to the object storage, right? It supports file to object transparency, breaks the metadata dependence, right? So it knows like when you copying the data from one place to another one, that the data was actually uploaded to the NFS mounting point, and then if that was actually sent it over to the cloud. So there's a cache on the storage gateway that can help with the life cycle of the data you're putting over there. Right, it's free. OCI Storage Gateway is free. You don't have to pay anything extra for that. So just here one overview of how that works. Right, you have your application servers on your own premises, and then you can have your storage gateway installed on your own premises base or even on the cloud. So it depends on how you want to implement that. And behind the scenes, you have the object storage that makes HTTPS requests to the object storage and send the data over there. So your application servers, you can map that through NFS mounting point. Okay. So what's the use case for storage gateway? Like cloud tiering, use storage gateway to expand the capacity of on-premises storage solutions without capital expenditures. Backups, you can use the storage gateway to have your backup plan, right? You can use that to copy data from on-premises and send that over to the cloud. For archive, you can use storage gateway for archive as well. And disaster recovery, right? So in case you want to create a disaster recovery plan from on-premises to the cloud, and you want to have a place where you can store the data and then get access in case something went wrong with your on-premises, so you can use the storage gateway to send that data over to OCI. So another way to send data over to Oracle Cloud Infrastructure using data transfer servers. Right, so data transfer service is when you want to send a huge amount of data from premises to OCI, and you don't have enough bandwidth to do it over to internet, right? So there's two options you can do with OCI. One is data transfer disk. We can send you, you can send a hard disk to Oracle Cloud Infrastructure with your data on it. There is a process that you have to go through in order to encrypt the data, to put the data on the hard disk. But you can ship that over to OCI, and then we can get that data and put it on the object storage and give it access to you, right? So there's a self-service portal inside of OCI that you can create that data transfer disk and then ship the data over to us. So you can also have a data transfer appliance. So if you have a really huge amount of data, you can use a data transfer appliance. Actually, Oracle ships that data transfer appliance to you, to your on-premises, on-premises location, and then you put the data on that appliance, and then send that appliance back to us, and then you can put that data also in object storage and give it access to you. Right. So just to give an idea, this is like a chart that gives you how much time it will take to upload a data using internet, right? So if you have 10 terabytes of data, if you go into a link that is 10 megabits per second, it might take you 90 days to do that. If you go to a link of 1 gigabit per second, maybe in 22 hours, you can upload those 10 terabytes of data, right? So here's where the sweet spot for data transfer services, right? All customers that has links on under 100 megabits per second, and you need to send a huge amount of data to the cloud. So that's where the data transfer will be a really great services for. Okay. So here's the summary. We went over to describe and validate storage performance, both for NVMe and block storage. We use volume groups. You understand how to use volume groups and manage backup and snapshot and cloning with that. Describe file storage performance options. Utilize S3 compatibility APIs to enable that with Amazon S3, and understand data backup and migration options. All right, so thanks for watching and have a good day.